Hello, everyone. Welcome to today's webinar. Today, we're going to talk about supporting our high performance workload with the right storage layer for that. And that's today we're going to talk about Amazon FSx for NetApp ONTAP and how it can help with our high performance workloads. Before we begin, I would take this minute to start introductions. I'm very lucky and excited because I am joined by two experts in the field, joined by Paul Manti and by Ayman Selmi. Hello, gentlemen. How are you today?
We're doing well today, Danny.
Hey, Danny, hey, Paul.
Hey,
We are
great.
going,
Great
yeah.
to have you both. So today we're going to talk about both a little bit about the business and the technical aspects of high performance workloads and the right storage environment for that. Before we begin, I'll take this minute while other people are still joining the webinar to talk a little bit about housekeeping. If you have any question during the presentation, feel free to ask it in the Q&A part of this webinar, and we will answer it during the presentation, so don't hesitate. At the end of the webinar, we'll have a dedicated Q&A session where we will answer questions asked either during the presentation or if you have any questions that you're reminded of at the end, feel free to post your questions then. If for some reason we don't get to answer your questions due to lack of time, don't worry, one of us will return to you with an answer. And with that, I think we can begin. And I think the first, now that we've introduced ourselves, we'll be very happy to hear a little bit about you. So how are you? How much are you familiar with Amazon FSx for NetApp ONTAP? Paul Lyman, what do you think about the level of knowledge of our audience?
I think FSx for NetApp ONTAP is really familiar on the EDA space and HPC space. I can see that from our customers. So I'm expecting to see a lot of people already knows about FSx for NetApp ONTAP. Let's see.
Yeah, I
Yeah,
tend
I'm gonna agree with I'm in there.
Yeah, I agree with the two of you, but don't worry if you are part of the minority who haven't heard about it. Don't worry, we'll talk a little bit about what is this magical service. Liat, is the web? Do we have the results? Oh, and I see that indeed a majority have learned about it, haven't used it yet, but at least they know about it. And we do have some people who use FSx for ONTAP for storage on the AWS workloads, which is great. But we do have a significant number of people who know a little bit about it. So let's continue so we can enlighten you. Okay, jumped here. So first of all, before we talk about the storage layer, what are high performance workloads? So I think it's very simple to give examples about different verticals and how they use high performance workloads. Of course, there's energy and geoscience, financial service, scientific research, software and large scale developments all have their unique usage from simulations to modeling to very large code bases. But sometimes I think in the conversation, sometimes we sort of lose what is the impact of high performance workload on the business. And for that,
And Danny, I really
oh,
wanted to jump in and talk about that here on these high performance workloads. I think this is a point that's not always made very well, is that if you really look at what oil and gas exploration means, it means, am I going through upstream and finding the right places and doing the right exploration and doing the right geology simulation work so that when I go to actually create that huge capital investment to go pull the oil out of the ground or pull the gas out of the ground, will I be successful? Financial services, right? There's huge upside and huge downside risks they're trying to avoid through this modeling. Personally, I come out of the high-tech EDA semiconductor space. And the thing that's very common there is we're talking about development engineers who cost per, on a cost annual cost basis, they're 7 to 10 times more expensive than the infrastructure, right? And so their ability to get through work and to minimize the amount of time they are waiting is not only crucial in terms of that project, but it's crucial in terms of the business success of that enterprise. So if you bring a better chip to market ahead of your competition, and when I say better, better power, better performance, better area, it not only impacts the top line in terms of you win a design win if I've seen statistics that say the first mover in a space in the EDA space wins 80% of that market. But it also directly impacts the profitability of the company as well. And so if you consider that the cost of these engineers or the cost of these scientists are probably 10x the infrastructure, that opportunity cost is probably another 10 to 100 times more than what that infrastructure is. So I think that's the key thing. And what we do, so if we could flip to the next slide, it starts to shape what the requirements are on these on the storage that serves these high performance workloads. And before I touch on each one of these, I'll also point out these tend to be global teams where you have people in Israel, you have people in France, you have people in the United States, you have people in Asia Pacific who are all working on the same project. And one of the key things that FSxN brings, and that you should require out of your storage, your high performance storage grid, is that ability to seamlessly move data from one region to another. But on top of that, these HPC customers really care about predictable performance. Are they getting consistent low latency, high throughput? And the latency is really measured to how long is that engineer waiting for results, or how long is that scientist waiting for results. The number two, this elasticity and scaling. I've seen huge impacts where companies have taken 10 years, say, to grow to 100,000 cores for their grid. And then last year they grew to 200, and next year they're going to grow to 400,000 cores. And why are they doing that? Because they're seeing their revenues grow tremendously, as well as their stock price growing tremendously in this AI-driven age. So that ability to seamlessly expand and do things, you could never on-prem go from 100,000 cores to 200,000 cores to 400,000 cores in 2 years. That's just not something you can do on-prem. High availability, as I mentioned, with the costs of what these developers and these scientists are doing, of the scientists and developers themselves, not to mention the opportunity cost. High availability becomes critical because we can't wait on them to finish. We can't wait for an outage or something like that. That will set the project behind. And then, of course, despite all these huge opportunity costs, being efficient with your spend so that you're not over provisioning, that you're not spending money you don't need to, is also a critical importance. Because then you can shift the dollars to where you do need to have them. Does that make sense?
Yeah, it makes perfect sense to me, and it was exactly what I was looking for. So I think that sometimes we get lost in the technical details, but sometimes lose sight of the business aspects and what are the considerations. When you have all these very serious professionals sitting in a room trying to find considerations. So I think having the background, the introduction that you gave us, is a very good intro to Ayman, who will guide us through the technical details and explain what is the technology under the bonnet that helps run these very important, very high performance and high demand workloads. So Ayman, take it away, please.
Yeah, so I think I have to start by introducing FSx for those don't know the service. I've seen from the poll that a couple of people that doesn't know the service yet. So it is one of the native storage service that AWS offers, delivering NetApp ONTAP as fully managed service. FSx has a set of built-in enterprise-grade storage feature backed by NetApp ONTAP software to provide values for various workloads, especially EDA and HPC. Among them, we see accessibility, resilience in data protection, data security, price and performance. That's kind of really important in this kind of workloads. And finally, data mobility and copies. For the next slide, I'll try to unpack those challenges that Paul and you, Danny, mentioned, and show the value of FSx to these specific workloads.
And before we get to that, it's time for another quick poll. So what is your biggest performance challenge today? Gentlemen, what do you think we're going to see here? There's unpredictable latency, throughput bottlenecks, IOPS limitation, handling concurrency at scale. What do you think is the one of the biggest issues that trouble people in the industry?
I think I'll go for throughput bottleneck. That's what I see from the field. a lot of customers grow their compute in the cloud dramatically. And if the storage layer doesn't follow, then we hit the bottleneck directly. And that's really very bad for
I
applications.
think either that or handling the concurrency at scale. And I think that's something we're seeing in the EDA space where, like I mentioned, they go from 100,000 cores to 200,000 cores, and they all tend to be hitting the same volume, the same file at the same time.
Yeah, do we have the results? Oh, and we do. And I see that we do have a surprise in today's poll, that the most common problem troubling our audience is unpredictable latency. To be honest, I myself.
But I think, Danny, it's valid for all points
Yep.
are valid in this space, right?
That's
You have
for
latency, bottleneck, throughput, and this kind of
Yeah. I not say that I'm not super surprised.
What lens?
Oh,
yeah.
Sorry there. So
I was just going to say,
there you go,
it could be
Paul.
what lens you're looking at.
Yep.
In some ways, those are very similar, and it all just depends upon how you're looking at your problem.
Yeah, I agree. I think from my experience when I was working in a fintech with lots of actuary modeling, that was unpredictable latency was a major issue. That was almost 10 years ago now, but I still see that it's still a plague today. And with that, Ayman, please continue. I'll let you have the stage. So we'll talk about predictable performance and how to avoid this unpredictable latency. Go ahead.
Yeah, so if we take EDA HPC workload, they demand predictable and consistent storage performance, particularly during simulations, verifications, and tape-out phases where delays can directly impact project schedule. FSx for ONTAP, I think it's designed to deliver fast, predictable, and consistent performance through these three key parameters and dimensions. Throughput, capacity, NVMe, memory and cache, and SSD storage resources. So let's start by talking about the throughput. Throughput capacity is really important to determine how much data can be read and write across the network, ensuring simulations and verification jobs to receive a consistent bandwidth. So NVMe, memory, and cache accelerate metadata operations, and we see in the field that this kind of workloads requires high metadata operations, which is critical for EDA to manage millions of small files and design files. The SSD, yeah.
Go ahead. Sorry.
The SSD performance tier provides sustainable low latency access to datasets supporting parallel engineering workloads. Target these capability, ensure engineering team to maintain predictable completion jobs, consistent user experience, and reliable performance throughout the design lifecycle, which ensure storage does not become a bottleneck during critical design milestones. Paul, I think you have, go ahead, Danny.
So just a quick question for me. So knowing our audience, they're very savvy tech people, even if they, especially let's take the example of those who haven't heard of FSx for ONTAP. So knowing our audience, they'll probably want to open their Sandbox AWS account and would want to, let's say, launch a test FSx for ONTAP. So from what I understand, I open the console, and if I want to launch an FSx for ONTAP and I want to play with it, the configurable parameters with which I can determine my performance is throughput capacity, SSD, number of IOPS, and if I'm already wanting to start with high performance workload, I can play with my in-memory cache, and if I really need to boost it, I can opt for a file system with NVMe. Is that correct?
Yeah, exactly. So we have a set of options that you can play with, and you can independently, so that's the magic, independently select and modify those kind of set of configurations to make sure that we have the right performance and capacity that can handle the type of workloads that we wanted to do on the FSx or the storage. The goal is to make sure that the compute or the operational or jobs that we run in the compute can be handled through the storage service as well.
Brilliant. And now we'll hand over the stage to Paul to guide us over one of the customers' story who chose FSx for ONTAP for those reasons. Paul, go
Yeah,
ahead.
this is a story about ARM. ARM is traditionally has been an IP provider in terms of providing CPU and GPU core designs to other customers downstream to incorporate into their own systems. So they've generally created a logically consistent block that then gets imported by other customers and placed and routed onto chips. They've chosen AWS and FSx for NetApp ONTAP for a variety of reasons, but this predictable performance is a big reason why they're able to shift their overall business model, and now they're getting into building or to doing the hardware design, to doing the back end design, the footprint, the planning of this, and then selling that as IP. They don't actually sell end products into the market; they sell it to other vendors. And this expansion is allowing them to, achieve greater growth in their market space and take additional share. So I think they turn to FSxN for predictable performance, but when you look at these numbers, you can also see they're a big plug for scalability. I mean, they're running close to 500,000 CPUs in Amazon Cloud with more than 10 million jobs submitted daily. But I think the big thing here is they've seen a 50% reduction in processing time. And this is really engineers going, hey, normally I've been constricted to running on the 2000 cores that I have on-prem, but now I suddenly have 4, 5, 6,000 available in the cloud that I didn't have before. I can get the job done in half the time. And when you can get the job done in half the time and get that kind of predictable performance, you're going to become more productive. You're going to get your design wins. You're going to see your market expand and your company's revenues grow accordingly.
And I think with that, time for another poll. Yeah, if you can send it away, please. Right, so how do you currently handle your performance spikes? Do you over provision? Do you tune it manually? Do you auto scale or use automation? Or you still don't have a clear... So once again, I'm here being the optimistic. Being the optimist, I believe that our listeners are probably using auto scaling quite extensively, using automation, and they're on top of their game. Hyman, Paul, any opinions about that?
I admire your optimism, Danny.
Yeah, I'll go for auto scaling. I think that's what customers in the cloud, because cloud is for elasticity, and I think auto scaling and automation is really the key here.
Okay, let's see if we've got the results. And I am glad to say that they're interesting to say there's an even split. So some people over provision. We do need to meet our customers' SLA. Some people manually tune their environments to meet performance peaks, which is also fine. Sometimes if you have peaks, quite rarely a manual tune-up is a very good option. Auto scale and automation, that's living in the cloud with the elasticity and scalability. And if you don't have a clear strategy, I imagine you're going to have to get one in the next latency.
I'm going to give a real quick plug here, Danny. I'm seeing a lot of customers start to adopt Workload Factory. I know it's not part of this FSxN presentation today, but Workload Factory is helping them all on that journey from over provisioning or no clear strategy to understanding what the manual variables are to ultimately auto scaling and auto provisioning.
So for those who don't know, NetApp Workload Factory, for the quick plug, it's an orchestration tool by NetApp to sort of give you out-of-the-box tools to get the most out of your FSx for ONTAP. We have some some webinars about that, so check them out. And my favorite thing about Workload Factory, do you know what that is, Paul?
It's free.
Exactly. You read me like an open book. Precisely. And by the way, gentlemen, if you can answer the questions in the Q&A thread, I'll be very grateful to you. And with that, we can go over to elasticity and scaling. Ayman, the floor is yours.
Yeah. So these environment, these workloads are highly dynamic. We have different phases. We have front-end phase and back-end phase. We have different type of workload, different type of tape, like IO profiles, verification campaign, large regression runs, simulations, tape out activity. And the amount of storage and IOPS and throughput increased dynamically from the compute sides, because in general they have a scheduler that can run or borrow hosts and EC2s to run those jobs. And increasing the storage dynamically as well, it's for a limited time of period of time is really key. That's why FSx for ONTAP is really a very good candidate to be plugged into these computes. And it addresses these scale out or scale up activity from the compute sides with single high available pair. As workload demands increase, additional resources can be allowed. So increasing throughput during verification, simulation, for instance, or tape out activity, we can scale performance, SSD performance or capacity independently from throughput to support metadata intensive design workloads or provide additional performance for peak project phases without changing any mount points. When project activity decreases, we can reduce also throughput automatically and SSD resources. And how do you think that ONTAP do that, guys? We have seen, if you have followed me from the beginning, there is 3 layer of performance that we can adjust and modify to play with these metrics. What do you think?
So my guess would be you have a single file system, so you can either increase the throughput capacity if it's bandwidth, or maybe add more CPU underneath. Another probably, and one of the things that you can do it independently of the first one is that you can add more capacity if you need, and more SSD, and by that more guaranteed IOPS. Which is great. And last but not least, you can add more cache. So the ability, especially if you have an influx of cores, then maybe you can cache some of them and offload it from the CPU.
You spotted right. That's exactly the case. But sometimes one single file system is not enough. That's why if you flip to the other side, adding more file system in the scale out FSxN to support larger design teams and concurrent projects. So the next question for me, how application can take advantage of all these resources by having multiple file systems without any change on the mount point or on or any rebranding or refactoring from the application perspective. This is where Flex Group comes into the picture, which represent a single namespace to. It's not there, but I wanted to talk about it because it's really important and key for our audience to understand how we can get advantage of having multiple file systems to get a good parallelism and address a huge amount of data and throughput that coming from computes. So because for EDA workloads, and it's particularly valuable because design repositories are often contain millions of small files and big files and generate highly parallel access pattern during simulations and verification runs. So engineering teams with the Flex Group continue to use the same mount point, the same namespace, while ONTAP and FSxN transparently leverage all available storage resources behind the scenes. So you don't have to think about managing multiple file system or or changing mount points or namespace to your application. Nothing changed for you. You attach more file systems and you get advantage of these parallel environments. The results will be higher throughput, greater concurrency, and improved scalability for these large EDA and HPC workloads. So, Paul, I think you have a very, very good example to tell us about it and show the elasticity and scalability of this storage for your customer, Vitesco.
Yeah, so Vitesco is they're a developer and manufacturer of advanced powertrain and electronic control systems for automobiles and other mobility. And I think this is an interesting thing because it not only shows scaling. It's funny, all of these reference examples show various aspects of what we're talking about, and they chose ONTAP because of all the things I mean that you've been talking about. But what really leaps out way beyond the storage savings cost or the more compute cores utilized is that they got their simulation turnaround down from a week to a day. And when you look at this ability to scale like that, instead of engineers waiting around for an entire week to get the results of an experiment they were trying, they're getting it tomorrow. And this means that in the course of a week, they can get 5 times the amount of work done that they used to get done. And that has tremendous value to Vitesco and to any other customer that's seeing these kind of accelerations due to the scalability of both the vertical as well as the horizontal scalability that FSxN brings. So going back to the overall business benefits, I mean, when your engineers can be 500% more productive, you're going to do some very interesting things in the market.
Great point.
So I think another point is availability, not losing time, and how exactly we handle that. And I think another question that I wanted to ask you is that we've talked about the scalability and elasticity of FSx for ONTAP. But let's say I find out, I find out that I have a latency spike. I do an analysis. I find that I need to scale up. I need to add more. If it's add more throughput, add more SSDs, etc. How do I do this? How do I plan my maintenance window? How do I shut down my business? I'm going to lose money about that. How does that work?
So practically, FSxN can scale up and down without the need to interrupt the service. Of course, we can take as a maintenance window to kind of protect the application from a sudden something that can happen like behind the scenes. But it's a scale out or scale up or scale out file system without interruption, and that's really the magic behind that. But there is a really key point that FSxN put into the tables with this high availability architecture. EDA workload in general run large simulations and verification jobs that can execute for hours and even days. And sometimes when we need to grow and to scale or elastically scale these dimensions that I have mentioned before, we need also to make sure that even in a scenario of a disaster, even if we don't have a maintenance window, we can survive and we can have our accessibility and our data accessed through this incident, right? And that's what high availability architecture of FSx provides, where the data is synchronously replicating between nodes, because the passive node is always up to date and there is no data loss in the event of failure. So if the active node becomes unavailable for a reason, operation automatically fade over to the standby node, helping maintain access to design data and minimize disruption to engineering teams. For EDA workloads, especially, the value is not simply high availability, because that's really key, but avoiding costly interruption can be really impactful for them. Having an interruption on the service can impact productivity, extend your verification cycles or simulations, ultimately delay time to market, time to tape out, and that's really disastrous for EDA customers.
Yeah,
I think, Paul,
cannot
you
miss
have
the
an
show.
excellent example. Yeah, go ahead. Sorry, Ken?
Gosh, I was just following on. No, let's advance the slide. But I was just following on to what you were saying that
Yeah,
you cannot ever miss your tape out date, right? That's
absolutely.
those windows come along when they close, they're closed. So this is another interesting example around HA. You can see here they achieved exactly what we were advertising, a zero RPO, and the RTO was 4 hours. But speaking of another anonymous customer, I was talking to the CIO, and he said, it's not the developers or the processes that are the bottleneck for us developing new chips. It's the infrastructure. And so they're becoming more and more heavily dependent on that infrastructure to get their products to market on time. And this is one of the fastest growing EDA companies on the planet right now. And with that, the bottleneck, you just cannot afford to have downtime, right? You cannot afford to do anything that impacts the development productivity of your organization, whether you're a company like ARM or a company like Vitesco or this scientific research company. You generally just can't afford to have downtime, even with your very large HPC grids. And so having a viable HA strategy is incredibly important. Back to you, Eamon and Danny. Let's talk about some cost and performance cost efficiency.
So yeah, here in the picture we see data tiering. But before that, I would like to call out a built-in capability that FSxN has, because I think it's really important in the EDA space and for HPC workloads. I'm talking about the duplication, compression, and compaction that helps reduce storage costs while maintaining performance. Why storage efficiency matters for HPC environments? Libraries, I think, in EDA space, like tools and these kind of things, significant provide significant deduplication opportunities. And also, when it comes to projects, often we reuse the same identical IP and design components. FSx deduplication and compression, typically we see in the market, in the field from our customers, provide and deliver 30% storage efficiency for these workloads. I can set some examples, like as I said, there is multiple phases for EGA and HPC environments. So for instance, front-end design environment usually benefits the most from the duplication, and because it has a huge number of shared libraries and tool sets. In the other hand, backend physical design benefit the most from compression than the duplication, because it has larger and more unique data sets. To complete the picture, with data tiering, in most ADA environments, only a small portion of the data is actively used, and we need a mechanism that offload the data that is not accessed for a long time to reduce the overall cost of the service of the file system. And typically, we see that like completed project or historical design iterations, previous tape outs are not anymore active. So we need to find a way to move it to a lower tier storage. And that's what happened in the FSxN. By keeping active data on high performance SSD, while transparently moving inactive and cold data to the lower cost capacity pool, to reduce the high cost of SSD. In the EDA space, from my customer from the fields, we see only 20% EDA data is actively accessed, while 80% is cold. And you can imagine the gain if you move 80% out of the SSD. It's really a game changer. This allows organizations to optimize storage costs without impacting performance, because your active data is still on SSD. even though some projects needs to be rehydrated and reactivated again, FSX will move these blocks from the cold tier to the hot tier dynamically and immediately when it's needed. So it's really something that it's recommended for these EDA workloads. Something that is really important as well, and I see it a lot in the EDA space, projects are rarely grow in a predictable manner, right? You have a new IP block, you have a larger regression campaign, or additional design team wants to increase the storage requirements. With the thin provisioning, storage can be presented to a project based on expected future needs without really allocating any space upfront. So this allows engineering team to start project immediately with the capacity that they require or they think they need, while storage is consumed only when data is actually written. And that's really an important, and it's a game changer for this type of workloads. As design repository grow, we need additional capacity. We can add more capacity transparently, eliminating the need of having to change or to change devices or increasing or changing the model, etc., etc.
So I have a quick question there.
Yeah.
So basically, what I understand is, let's say I'm the storage admin. I need to allocate. I have some different clients who need different applications, and they give me their requirements. Obviously, they're not thinking about day one. They're thinking about a month, 2 months, a year from the start. When they grow, they say, "I need 30 terabytes. I need 100 terabytes. I need etc." But storage in AWS, especially SSD storage, which is the performant one, is not very cheap. It's quite expensive. And I don't want these SSDs to be dormant. So basically, what you're saying is I can, on paper, satisfy the long-term requirements of my different applications, but in reality, only get the SSD disk that I need. And when those, let's say here we have 3 applications, but in reality, it's more like 30 or even more. I don't need to actually keep a monitor on them. I can automatically grow my SSD pool as the applications grow and not according to projections that might or might not be true.
Is that exactly the case? And that's really a game changer for these projects, to not have a bottleneck on the capacity side, but to not over provision as well, which helps avoid extra costs on the storage layer that you don't need in reality at the moment. So it's dynamically grow when you need the data to keep project moving forward and to keep the capacity available for these applications and projects. This is really a key feature, and this is one of the most important feature that ONTAP has over the years. But before discussing, why we are using this and what are the use cases, let's explain what is snapshots within ONTAP. So snapshots providing instant space efficient point in time copy of the file system, because data is not really copied around, and snapshots are created instantly to have a point in time and pointers to the actual data file system, right? So for EDA environments, snapshots provides a simple way to protect their data locally before major, for instance, milestones such as tape out preparation or large regression runs. So you don't have to worry about your data with this. So this is a point in time. You protect your data. It could be immutable. So if engineering accidentally modify or deletes files, teams can quickly recover from a previous point in time
I'm
without
going to
destroying
interrupt for
entire
a
Simon,
environment.
second.
that's I think Paul wants
Yeah,
to
go
say
I'm
ahead.
going to
something.
interrupt for a second because I think my hair went gray early because of an issue where I wish I'd had NetApp. I
Oh,
was a design engineer. We were designing a major board. I was 12 months into the design. I was a month away from releasing first prototypes. I came back from lunch and my database was destroyed. So a whole year's worth of work was gone. And you can imagine how much my hand was shaking when I called IT and they rather nonchalantly said that they could restore from tape and that it would take an hour or two and they would call and let me know if it was successful. And I think all my hair went gray during that hour. And I came back and they said, well, yeah, we were able to restore you. And I hadn't realized, of course, that they were restoring me to where I was at midnight the night before. So I lost all of my morning's work. I had to come in on Sundays in addition to Saturdays to get everything cleaned up. And had I had NetApp, I could have just taken a snapshot or even set an hourly snapshot, and I could have just rolled back to the one that was working before lunch and lost no time, lost no work. And instead, I lost most of my hair and it all went gray. So this is, I think, one of the most powerful features that NetApp offers that we really need to figure out how to get into the hands of all those engineers and developers, like you were saying.
Yeah, exactly. And on top of that, Paul, these snapshots can help also build like a thin copy of the data without copying the data itself. That's what we call
Yeah,
it.
so there's no reason for them not to use it because it's very inexpensive as well. It's a
Absolutely.
few megabytes.
Exactly. That's what we call it in ONTAP language flex clone, which is built on the snapshots technology. And for EDA organization, this can be significantly important to improve engineering productivity. So for instance, I think, Paul, you had this before, maybe in your early experience. When design team want to validate a new tool version or test new design flow, they don't have to copy the data around and they don't have to duplicate the data. They can just create a snapshot and create
Well,
a flex clone out of it, and then do this verification campaign or create
so
an isolated environment to do these kind of things.
what we're really talking about the ability here is we've removed a lot of the barriers to experimenting on a new idea. Because a new idea is only as, if it suddenly takes justification to people in terms of why we're going to spend this extra money or why it's going to take this extra time to set up this additional infrastructure to try this experiment, the level of idea has to really be thought out. But this allows engineers to almost instantly and for very low cost try something out, and if it doesn't work, roll back. Or if it does work, continue building on it. So it really lowers that barrier to entry of experimentation and rapid prototyping.
Yeah. If you don't have NetApp today, you need to copy tens of hundreds of terabytes of data, uh, and that's time consuming, capacity consuming, and it's really costly. So with NetApp, you create snapshot instantly, you create a clone, present it to you know, your test team, or you want to test something or isolate some environments very quick, very instantly, and that's really a game changer. Uh, you have your own independent workspace while you share the same file system, right? You don't the primary file system will keep working with your application. You don't need to have a separation between the environments. The data is synced, so you have the same data. And this really reduces your consumption. You don't have to duplicate and move data around. This is, it gives you a tremendous advantage to faster innovate, to do more parallel development and testing, and better utilizing your both storage and EDA tool and license, right? That's really important. I think you have an example, Paul, to give it to the audience and to
Yeah,
show
so
the
I mean,
value of this.
if we look at Domino Labs, right? So they help data science organizations and accelerate their model development and really create a more collaborative environment for scientists to work on and work with. They got twice the performance at half the cost, which I think is tremendous. But I think the other thing we're really talking about with all of this, everything we've been talking about, and especially this cost optimization, is that it's really about the IT organization being reframed from being a cost center to the stewards of the development and enabling faster development, enabling wiser choices of how the company spends the money, right? So it's not just a matter of, hey, we saved you 50%, but we were able to help you reallocate the 50% that you would have spent on storage to something that's really going to help you move the business within the organization. So I think that's the key story from all of this and what FSxN brings in terms of predictable performance, availability, scalability, and the cost optimization is it really helps the IT organization become an innovation driver, become a productivity driver for the business.
And with that, thank you very much, Paul. Thank you very much, Ayman. So with that, to summarize, so what we've learned today about FSx for ONTAP. So first of all, it comes with predictable performance, getting our low latency, our SSD tiers, the predictable throughput, everything as said with based on the the state-of-the-art infrastructure in AWS. And speaking of AWS, you get the elasticity and scaling that matches the rest of your technological stack, meaning you can independently scale. You can scale performance, capacity, grow and shrink your SSD tiers, and specifically those, they are decoupled from each other. So if you find the pain point or the sort of the bottleneck, you know exactly where you need to apply pressure, add more resources. With high availability, you can avoid those downtimes, whether because of disasters or by upgrades or updates, etc., and not worry about maintenance windows or the ability to lose your deadlines. And last but not least, cost efficiencies with all the features that Ayman and Paul just listed. Think of all the things you can do with that money, not spent needlessly on resources. And with that, if you want to take the next step and try it out yourself, check out the test drive of FSx for NetApp ONTAP. Give it a try. And it's at the end of our presentation. It's time for our Q&A session. So I don't know if the questions have been answered in the Q&A thread. I was a bit preoccupied, but we do have a question that I see that was not answered. Ayman, I'll give this one to you. Edward is asking, how do you increase cache, both memory and NVMe?
So there is a when you create your FSxN from the AWS console, you have queues, right? These queues determine how many cache and memory you have in the file system, right? So if you find out that your workload demands, it's read intensive, and you need a large memory, so you change this queue, automatically it will change the cache, both memory and NVMe. So and changing this queue also is automatic, so you don't have to remount or you change your mount point or you do or refactor any accessibility to the file system. It's on in the fly, and it works without any disruption. I hope it answered the question for you, Edward.
Thank you very much. And if anybody else have some more questions, now's a good time to send them if you haven't already. So I'll give you a minute to do that.
Yeah, I'm sitting here thinking, Danny, some of my customers would benefit from a follow-on to this, maybe a little more advanced HPC webinar where we talk about, as we mentioned, and Eamon mentioned the snapshots and clones, but also some of the creative architectures we're seeing being used, leveraging FlexCache to help that scale out performance. And when they see a tremendous amount of concurrency or they're starting to have problems with throughput and latency, and could also cover the workload factory parts of things, because we're seeing customers increasingly, especially in the EDA space, turning towards workload factory. So this is my plug for the session.
Yeah, it's a great point, Paul, especially with the FlexCache. We are seeing this pattern, especially when you choose to burst your workload into AWS, not running it fully. We've seen this pattern coming from the compute, because if the compute scale or burst in AWS, you need to have a storage that can fall and do the same in FSx in the AWS, and that's where FSxN have value there and to provide this bursting and elasticity in the cloud close to the compute muscle. That's really a key.
We're seeing customers, as you say, not only burst to cloud using the whole flex cache, but then also handle massive concurrency within the cloud when they're doing whole designs in the cloud using
Yeah,
flex cache.
yeah,
So yeah,
absolutely.
it's got applicability at numerous and creative levels.
Yeah,
And
what
one of my executive customers said, because it really is the silver bullet for high performance and EDA workloads.
yeah, yeah, exactly. What I meant by bursting is not like having on-prem workload and running few uh, terabytes in the cloud, but in general, they use compute to run jobs, and these compute scale very, very like quickly, and they need storage to follow up that and to have very predictable and a parallel file system to absorb this scalability on the compute side to run these jobs. And that's where um, I have a really nice picture where I cannot share it now, but you see the scale up and down of these computes uh, to run jobs. So you have sometimes 1,000 nodes and then have 2,000 and then scale down and these kind of things. And that's where the storage has to follow and scale up and down to absorb this scalability on the compute side.
I mean, I would definitely love to see that, but I think we need to leave our audience hanging and wanting for more. So with that, I would first of all thank the two of you. Paul, Ayman, you've been very generous with your time. So thank you very much for that. I want to thank Liat for running this broadcast meticulously, sending the polls, making sure everything is working correctly. And last but not least, thanking the audience, for listening, for taking the time out of your day to listen to us, for sending interesting questions. We're eager to hear your feedback. And if you want to hear a more advanced webinar, as Paul and Ayman suggested, I also think it would be an amazing idea. If this something like that would be interesting of you, please write it down in the feedback, and we'll be very, very happy to whip something up for you. Thank you very much. Have a great rest of the day. Goodbye.